Hey everybody, we are going to be finally getting into talking about how our leavening agents, the chemical ones specifically, baking soda and baking powder work, now that we've spent a ton of time talking about acids and bases. And just as a reminder, in case you've kind of lost track, the reason why we talked about acids and bases first was because baking soda and baking powder, the chemical leaveners that we're kind of talking about right now, are themselves acids and bases, and their behavior, whether they're a base or an acid or both, will kind of explain how they work. We're going to start talking today about baking soda, and then we'll get into baking powder. All right. So, baking soda is actually the chemical NaHCO3, and its chemical name is sodium bicarbonate. So when you guys buy a box of baking soda at the grocery store, you're actually buying a box of this stuff called sodium bicarbonate. Now, sodium bicarbonate is a basic substance. So if I would take sodium bicarbonate, dissolve it in some water, and then put an indicator in there, the indicator would indicate that it is basic. So if I use like cabbage, it would be more towards the blues and the purples than anything else. So it's got a basic characteristic to it. And baking soda works in two different ways, and it kind of depends on what the recipe is calling for, but you'll see it work in two ways. The most common way that you see baking soda react is with acids in foods. And the reason why it reacts with acids in foods is because they undergo a process together that we call neutralization. As you've hopefully kind of caught on, acids and bases are opposites of each other. And so what happens is when I mix together an acid and a base, they cancel each other out. And that is the case in baking soda. So if I take baking soda, sodium bicarbonate, and I put it together with an acid, they always make the same things. Regardless of what the acid is here, it's always going to make the same things. It's going to make a salt. It is not going to make the salt that you think about, NaCl. What it's going to make is it's going to make a salt that is a combination of the Na from the sodium bicarbonate and then part of the acid. So it's unique to each of the acids that you mix it with, and it kind of depends on the context. So I'm just not going to kind of tell you that right now because I can't be specific for every reaction. What it also makes and is really important is water, and that water will produce steam if you heat it up. And then, most importantly, and the actual thing that we're looking for in a leavener is it produces carbon dioxide. And carbon dioxide will show up in the form of these little tiny bubbles. And then when you heat those little tiny bubbles up, they get trapped inside your food product and they expand and puff up and then give you the lift and fluffiness that you're looking for instead of some weird, sad, dense, flat thing. Okay. The other thing that baking soda is able to do is it is able to break down with heat. So if you would put baking soda just in water and then, or not even just in water, but with something that doesn't have a lot of acid, and then you put that baking soda into an oven, warm environment, the baking soda will break down on its own through a process we call a decomposition reaction. And this baking soda will go through two steps. What it will do is it will go from baking soda into carbon dioxide, water, and then something that looks very close to your original chemical, but it's not. This is called sodium carbonate. And then as you heat it more, the sodium carbonate breaks into carbon dioxide and sodium oxide. So even if you don't have an acid available to react with your baking soda, it will still break down on its own if you put it in heat. Now, the speeds of these reactions kind of depends on the conditions around it, and I'm going to actually go through and tape some videos of myself testing a bunch of these different chemicals in different conditions, and you'll kind of see what the best conditions are. All right, baking powder is actually baking soda. So it takes baking soda, and then what it does is it takes a powdered acid salt, which is usually sodium tartrate or tartaric acid, and then they mix that together with some starch, like cornstarch, to keep things dry to prevent it from clumping together. So if you think about baking soda as a base, Baking powder is the base baking soda, but it also has acid mixed into it, and that is really important. And the reason why it's really important is because the acid and baking soda mixture remains unreactive when it's dry, but it is immediately reactive when water is added. Baking soda, that is not the case. Baking soda, you need to make sure that you add an acid into the recipe to do the reacting with the baking soda. Baking powder can react completely on its own as long as it gets wet. And that's really important, and a reason why they put the starch in there is to keep things dry so that you don't end up having your baking powder react over time. Once you open your baking powder, you expose it to moisture, and when you expose it to moisture, it does sometimes ruin the effectiveness of a particular recipe. So they actually recommend like tossing your baking powder and buying a new one every so often. I think there's an expiration date actually printed on the little container of it, because it does lose its effectiveness. So if you make muffins and they don't rise, and you're like, hey, I use baking powder, your baking powder might be not great anymore, and it might be time to replace it. Okay, so baking powder, a lot of times they say that it is a double acting baking powder. And so what happens is, immediately when you mix baking powder and water together, you will see a fizzing action happen. But if you give the baking powder some time, what will end up happening is that when it heats up, it also produces carbon dioxide bubbles. So they call it a double acting, because you get a quick fizz at the beginning, and then once you get the product heated up, it also fizzes up again. Excuse me. So in the case of the double acting baking powder, the first reaction is exactly the same as the previous one with the baking soda. The second reaction, though, is with a chemical called carbonic acid, H2CO3. And H2CO3 is kind of an unstable acid that if you heat it, it will produce carbon dioxide and water. So that's where you get the second reaction. One is the first reaction with the acid mixing together with the baking soda, and the baking soda and acid are together right in the can, and as long as they stay dry, they're not going to react. If they are wet, they'll react immediately. The second reaction happens when you heat it, and it releases extra carbon dioxide. So like I said, I'm going to be going through, and I am going to be running some experiments that you guys are going to be working on kind of a lab, and you guys are going to decide in what situation you think what leavening agent is best. All right, if you have any questions, don't be afraid to email me, or we can set up a meet time and get things cleared up. Good luck.